Welcome to Industrial PLC Applications Level 2. This video is on TP, or Timer Pulse Instructions. After completing this video, you should be able to identify a TP instruction and add a TP instruction to a program. Often in automation, a device must be activated for a short period of time. There are a couple of ways to accomplish this. One method is to use a TON instruction that employs a couple of the instruction's components to make it work. The other is the timer pulse. They both work, but their applications are different. This video focuses on the TP. Another will compare the two methods and when and where they are used. A timer pulse instruction does exactly what the name suggests. It turns on its output for a fixed period of time if triggered. Period. The big difference is in its timing chart. Looking at the timing chart, you can see that the Q is set once .in is true. Okay, great. The difference is that the Q stays on even if the .in is dropped. It will stay on for the entire program time. If the .in goes high while Q is running, it's ignored. It will not affect the Q until the Q has run its course. Given the simplicity of this timer, there's only 4 programmable parameters that we are involved with. The first, of course, is the TP. In this case, is TP_3. So the .in, just as before, is the input that triggers the instruction. However, in this case, it is only effective if Q is not set. If Q is set, it's ignored. TP_3.pt is the place where the program time is stored, and the TP.et is where the elapsed time is stored. The final program parameter comes with the instruction. That's the TP3.q, the output. You can think of this output like a latching coil. That is, it's reset once the elapsed time reaches the program time. Once it's turned on, it's latched up and gets unlatched when the elapsed time has elapsed. Okay, so we're going to do a quick demonstration of the timer pulse. I have one already programmed. I'm using a bit called heartbeat to trigger it, and it's going to turn on like auto saw for exactly 4 seconds. Now the heartbeat comes from a TONAV that I've programmed in our timer timing functions, and you can see it on the bottom here. It's going to be on for 4 seconds on my off delay. It's going to be on off for 4 seconds because we're going to delay that start for 4 seconds, and then we're going to delay the turning off once it is on for 1 second. So basically it's a 1 on 4 off timer. And I'm going to, on the second program, I'm going to add a second run which looks like the first, but I'm going to use the not heartbeat. I'm going to use the opposite state because I want you to observe how the pulse timer stays on for a given period regardless of what's happening to the input. And the best way to do that is to use 2 different timers. So we'll grab the timer counter, go to TP, we'll drop that onto our rung, and we're going to give this let's give this a nice long time of 5 seconds. And we'll turn on another output. Digital output 4. And we'll download it to the PLC. Okay, so we can see our heartbeat's already working, and you'll notice that our long heartbeat has been set. Doesn't matter if it's turned off, it will keep going and do the 5 seconds. The second it gets initiated, it will do it for the entire 5 seconds on the bottom one, and on the top one it's behaving, doing the same thing. Regardless of what happens to the heartbeat, it gets triggered, it stays on. So this instruction, the output cue, you can think of it like a latching coil, that it gets triggered, it latches up and stays on regardless of what the input does, and then afterwards, when the elapsed time equals the PT time, then what happens is it's like the latching is unlatched and the output turns off. If the heartbeat comes on twice during the count, the output ignores it. You can see it doesn't matter, that heartbeat came on the bottom one just as that was finishing up, so it missed its opportunity to re-trigger it. So when you're working with a timer pulse, if it's something you need to go on for a fixed period of time regularly, the timer pulse might not be your solution. It might not behave the way you expected, especially if you have something that's going to shut down for whatever reason, say for example a stop push button. So that's how the timed pulse works. In our next video, we're going to compare the timer pulse with using a TON instruction to do the same thing, that turn on an output for a period of time, and then when the time is up, turn it off. Until then, thanks for watching, and see you next time.